so far, this is probably seems pretty boring and limited to you, because the system only knows exactly what we told it. So any question that I ask, I have to have already provided exactly this answer. So if I say, it tells me that Brian hates cheese, but you know, that's really inadequate. Brian hates racism, and Brian hates Led Zeppelin, and you know, I mean, there's lots of things that Brian hates. And similarly, there's lots of things that Brian likes that the system doesn't know about. It doesn't know Brian likes the Beatles. Okay. We'd like to be able to generalize this a little bit. So I'm going to put in a little bit of data here. Oops. Did that work? Probably not. Yeah, it did. Okay. Right. So so-and-so is the parent of so-and-so. Yeah. So now I can ask who Brian's parents are. I get two answers. And I can ask who Brian's children are. I get one answer. But I can do more than that. I can also do this. Here's where it starts getting interesting. So there's a special kind of assertion that I can make called a rule. Oops. There. This isn't going to work. We'll see. Okay. Let's see if it worked. Yay, it worked. Okay, so the important thing to note here is that I didn't tell the system explicitly that I have a Grandpa Joe and a Grandma Minnie and a Grandpa Max. The system inferred that, derived that, from information that it had about parenthood plus this rule. So rules are the logic programming equivalent of procedures. So a rule looks like this. By the way, don't be misled by the fact that we have parentheses around anything. In this query system, we are taking advantage of Scheme's read mechanism that turns stuff in parentheses into box and pointer diagrams. But we're not using Scheme's evaluator. There isn't a procedure called rule that we're calling. There isn't even a procedure parent or a procedure grandparent. All of these things are just essentially strings of text, although you know what they really are is lists, being matched one against another. So the way rules work is this. Well, first of all, when you type in a query to the query system, the first thing it does is look for assertions, non-rules, in the database that exactly match the query, exactly in this sense of question marks matching anything. And any assertions like that that it finds, it gives you as a result. So if I had made any direct assertions about who's the grandparent of whom, then we would see those. Then it looks for rules. But it can't look for a rule that in its entirety matches a query, because this rule is too complicated for that. It looks for a rule whose conclusion matches the query. So my query was grandparent question mark who Brian, and this rule says grandparent question mark old question mark young. Do those match? Yeah, they do. Grandparent matches grandparent. Question mark who matches question mark old. And Brian matches question mark young. Okay? So the query I asked does match the conclusion of the rule. If that isn't true, then we just skip over that rule. But if it is true, if the conclusions match, then we take the body of the rule as a new query to evaluate. And I'd like you to understand, I hope you should just instantly understand, but if you don't, let me help you understand, that this business of set up the values of variables, old and young, and now evaluate the body, that's a lot like how Scheme handles a procedure call. It's a little bit different because it's the query evaluator, not the Scheme evaluator, that we use to evaluate the query. And the result of that evaluation is true or false. So we want to know, is this true? This is the body of the query. And is like a special form in queries. And or is another one, and not is another one. So assert, bang, rule, and or not, those are the only kind of reserved words in this system that have special meanings. So what and means is if all of its sub-expressions are true, then this is true. So it's a lot like the procedure, well, special form, and in Scheme, which says return the value true if all the arguments are true. The difference is you don't see true printed out. Instead, what happens is if the result is true, then the query system says this is a match. And what's actually printed out is the original query, but with specific values substituted for the variables. So the query was grandparent question mark who Brian. And every time it succeeds in matching that through the use of this rule, it prints out grandparent so-and-so Brian by finding out the value of who. Well, So now what it has to do is try to match two queries about parent, namely parent question mark old question mark middle, parent question mark middle question mark young. But just as in scheme evaluation, queries are evaluated in an environment. The environments are a little different in details, but to a first approximation, it's the same idea. So when we matched my query, grandparent question mark who Brian, against the conclusion of the rule, we came up with some constraints on these variables. So question mark who has to be the same as question mark old. We don't know who it is yet, but whoever it is, they both have to be the same. And question mark young has to be Brian. Okay? So now we look for parent question mark old question mark middle. Since we haven't yet constrained either old or middle, we're seeing middle here for the first time. Every single parent assertion in the database will match that first parent clause in the and. It's just parent, variable, variable, and we get every single one matches. So, you know, parent, Tessa, Bob, matches. But then we have to also satisfy parent, question mark middle, question mark young. So in the case parent, Tessa, Bob, we've bound Tessa to old, I'm sorry, old to Tessa, I should say. We've bound middle to Bob. And now we have to match parent, middle, young. Middle and young are both bound. Middle is Bob, young is Brian. Is Bob the parent of Brian? No, he's not. So we reject that particular set of bindings. Now we look and we find another assertion in the database that says parent, question mark, mini, I'm sorry, not question mark, parent, mini, Tessa. Okay, fine. Old is mini, middle is Tessa. And now we're looking for an assertion that matches parent, question mark, middle, question mark, young. But middle has to be Tessa. It's constrained. It's bound already. And young has to be Brian. So we're looking for an assertion, parent, Tessa, Brian. And we find one. Tessa is my mom. And as a result, this line is printed as a result of that set of circumstances. Yeah? So would it be more efficient if the two and clauses were flipped in order? It would for this particular query, but remember you can also ask the question, grandparent, mini, question mark, who? And for that it wouldn't be more efficient. But it's a good thing to think about. And sometimes it's a crucial thing to think about because what you get is so inefficient that it never gives you an answer at all. It sits there looping. So we're going to see some things about that coming up later on.